Welcome to Sweet Life Beat Life. We hope this video helps.
You begin by measuring, not guessing. Run cProfile or pinstrument on representative workloads to locate slow functions. Once done, use timeit for tight loops to separate call overhead from algorithm cost. Make sure to capture memory behavior with tracemalloc so you know if allocation or CPU is the bottleneck. Keep inputs realistic and log baseline numbers. This allows you to evaluate the impact of changes and prevents wasted optimization on non-critical code paths. You focus on the hot path next. Replace naive algorithms with more efficient ones. Switch quadratic loops for sorting or hashing approaches when applicable, because algorithmic gains far outpace micro-tweaks. Use Python built-ins and comprehension syntax to leverage C-level loops. Make frequently used names local to reduce attribute lookups. When memory churn is an issue, reuse buffers or use generators to stream data, and minimize temporary objects. Once this is in place, reprofile to confirm the expected. You wrap up by scaling and validating improvements. If work is I/O bound, convert to Asyncio or thread pools. For CPU-bound tasks, use multiprocessing, Python, or native extensions to bypass the GIL. Once parallelism is added, run end-to-end benchmarks and unit tests to ensure correctness under concurrency. If performance regressions appear, revert to the last good baseline, rerun the profiler, and isolate the change. That troubleshooting step is your fastest route back to a working, faster build.
Thanks for watching. Consider subscribing if we helped you.